Hi everyone, today I will discuss my lesson plan about teaching accelerated motion, and the topic of lesson is verify the equation of motion, equation of accelerated motion. And I expect that my student is at medium level. They have experience with inquiry-based learning, and they can do experiment familiar with equipment. But this lesson is some first lesson of high school physics curriculum. So I think I will guide them to design the experiment at the basic level. After the lesson, I want my student to gain some skills like designing experiment or deducing consequence can be checked by doing experiment. First, the previous lesson, my student know what is accelerated motion, and the equation of linear accelerated motion is d equal to initial velocity and multiplied with t plus a half of at square. And I will show them the equipment is inclined track with a ruler, a steel ball that can be rolled smoothly in the track, two photogate connect with a digital timer, and a electromagnet. When push the button, the magnet will release the ball. I will ask them to design experiment with these equipment to verify this equation. But my students need to realize that we cannot measure A with the equipment, so we need to lead to a consequence to verify it, and the consequence is for a time interval is equal the change in successive distance is equal. And I will ask them to prove this consequence. The proof of consequence is when you have you see a motion and we start. We assume that this is the distance the object can move in the time delta t. Is S1, S2, S3, S4, and the distance t is this is this D1, D2, D3, D4. The proof of the consequence is for the time interval delta t, D1 equal to, and we assume for simple case, we take V0 equal to 0, so D equal to 1/2 of AT squared. So D1 equal to D2. We can move to that. The S1 equal to D2 minus D1. So it's equal to S1 equal to D1 equal to D1. S2 equal to D2 minus D1 equal D1. Similar with S3 and S4. So from this we can conclude that S2 minus S1 equal to S3 minus S2 equal to S4 minus S3 equal to 2D1. This is a theoretical way to prove the consequence, and once student can prove this consequence, I think they can easily design an experiment by we can collect the data of delta t and set the position, set the S1, S2, S3, and S4, and check whether the delta t is equal or not.
Can you repeat the consequence shortly?
Consequence shortly is a
your consequence here is different with inside of the lesson plan.
This consequence is for delta t is constant, so we can have this. So I think it's similar with the one is the lesson blank. It's equal with it too.
In formula it's easy, but can you formulate it in sentences?
In sentences,
What we want to
verify is the change in successive distance in a time in the equal time interval is equal.
Not bad.
Very good. And after that, I want my student to design experiment, and I think they can set the propagate at the position propagate at 2 of the position and connect it with the digital timer to measure the delta t. Repeat it with S1, S2, S3, S4, and check whether the delta t is equal or not. I will do the experiment. I will skip
So the series of S, because you arrange S first and then you measure the top. Yeah, so can you write a series of S first?
Yes.
S1 equal to what?
S1, because of the length of the ruler, so I set S1 equal to 4 centimeter. So S2 equal to 12 centimeter. 20 centimeter. Centimeter. So, and I have the data here. The position of S1 is at 12 centimeter. It's for me it's easier, 12 centimeter. So B is 28, C is 48, and sorry. Okay. No, it's the 7, 6. D at the position of
Can I choose F1 is 4 and F2 is 20 and F3 is 36.
F1 is 4.
F2 is 20.
S2 is 20.
And F3 is 36.
This one is 4. Oh yeah. Let's change and equal. So it's distant, this one. So I think this is the time interval between S3, time interval from S2 to S3. The delta T is delta T2, delta T, delta T3, delta T2 is from S and F1. So I think delta T3 is equal to delta T.
Do you think so?
But it's different with delta T1.
It's okay.
No.
I don't need.
Okay, so it's okay, but this data I choose.
Okay.
Simply try this distance, and if this fails, you try to withdraw also distance. So let's ignore S1.
Yes, I ignore S1 because I'm not sure the position of the ball is. I set it directly as it's. I set at 16 and the photo get E at 36. It's when it's at 6 and this is at 72. It's I think it's the arrow is accept can be accepted.
Let's do this. F1 is 10, 20, and 30. Or is the 25 and 40.
S1 equal to 10, then okay. S1 equal to 10. But can you choose a data that a little bit smaller? But because the ruler is
40 is okay.
but 40 plus with 47, we can have to put the ball here, so it's not accelerated here, or the
10.
it's 10 here, 10,
Yeah.
10, 25, and 30.
No, I mean S2 is 25.
Yes, S1 is 10 centimeter.
Yeah.
S2 here is
No, this is not S2.
S2 is S2. S1. S1, S2.
You mean that?
Yes,
And 20 and 30.
20 and 30. So the change in distance is not equal.
Now 20 and
20. So
Yeah, 20.
Well, we try different tests. We
okay.
and we can compare because all the time we can calculate acceleration.
20.
And it must be wrong. I don't use oral. It must be wrong.
It's a 1.345. 1.345. So I can.
Read it again. It's not oral.
1.3. Sorry. It's zero. Sorry.
Zero is okay.
Sorry. So I'm really loud. It's 0.337.
Wrong or wrong? Yeah.
Now set up with those
The consequence.
the
Yeah, do it
the old one. The old one. That's why it's 4 to 12. Can you put the ball? Yes, and see carefully what is the position of the ball.
Yeah, I check it before. It's at 12. 12 and 16,
Okay.
say 28.
Okay, do it. And record it.
going, what is going on here, what is problem here. My consequence is wrong. And you say it is correct.
Yeah, so
Why is this consequence is wrong and your consequence is correct?
because of little bit wrong. Yeah. Taste.
Okay, that's a big question. So it's enough. You take me later. Yeah.
Yeah.
Think about it later. Next.
Yeah. Thank you for listening.